Let's find out the method to solve equations and to check whether equation is correct or not. Here you are given with an equation which is a very common equation, which is the second equation of motion. X is equal to ut plus half at square. What is this x? It is just displacement. So what is ut? It is velocity into time plus half at square. You can take the displacement's dimension as L to the power of 1. What is the velocity into time? That means u into time. That is velocity, you could write length by time. That is L t to the power of negative 1 multiplied by time. So when you multiply this with time, you are getting only L. Now what is half at square? That is acceleration multiplied by time square. Half is a dimensionless quantity. Now acceleration is again velocity divided by time. Velocity is length by time into time square. This time by time get cancelled, and that means time in multiplied by time, that will become LT to the power of negative 2. Again it is multiplied with t to the power of 2. It will get cancelled. You are getting L only. That means this equation is correct as far as the dimensions are concerned. I mean, each and every equation, this term, whole term should be equal to this one. The whole term should be equal to this one. I mean the dimensions. This is the idea of doing whether an equation is correct or not by using dimension analysis. We have another question to solve. Here is a gas equation given by P plus A by V square multiplied by V minus B is equal to RT, where T is the absolute temperature, P is the pressure, and V is the volume. Here we are asked to find out the dimension of A and B. So we have written P plus A by V square, V minus B is equal to RT. V is here volume, not velocity. As you know that P plus A by V square, that means we cannot add quantities that doesn't have same dimension. That means when you add quantities together like P plus A by V square, that means this whole quantity has the dimension of pressure. That's why we are adding them together. We cannot add pressure and volume together. Can we? No. So that's the idea. So this is having in the dimension of pressure. That means the whole quantity of this one is having the dimension of pressure. So we can take A by V square is having the dimension of pressure. You take A here, you multiply P by V square. What is this V? It's not velocity, it's volume. Now, what is pressure's equation? What is pressure? It is force by area. What is force? Mass, acceleration. Mass multiplied by acceleration divided by area. That is L square. So, when you take this to numerator, you are getting mass L to the power of negative 1, T to the power of negative 2 multiplied by L cube the whole square. So when you multiply them together, m to the power of 1, L to the power of minus 1, that is here a square is also coming, L to the power of 6 coming. So it altogether it is L to the power of 5, T to the power of negative 2. So we are getting A as having this dimension. Now I am saying this quantity. This again quantity V minus B. This is multiplication. Cannot be equal to this one. Each and every term what you are adding, that one, that should be equal. That means we have V minus B that has a dimension of the volume. So you take V minus B has the dimension of volume. So what is B is also having? Definitely B is also having the dimension of volume. That means only the same dimensions are being added. So V is also having dimension B. So what is the dimension of volume? It is L cube. So we are getting the dimension as B, or B as L cube. Hope you got the answer right. Please go through that things again and you will find answer. Now